Welcome to the part 2 of the integration by partial fraction series. In this part, we will be going over the remaining two rules of the integration by partial fraction, which is where we have a px squared plus qx plus r, x minus a squared or x minus b. We must split the fractions into our first unknown variable a divided by x minus a, then our second unknown variable b divided by x minus a squared plus our third unknown variable c divided by x minus b. And then for our fifth rule, which is that polynomial px squared plus qx plus r, and we have x minus a and another polynomial which we cannot factor, we must take the first unknown variable a divided by x minus a plus an unknown variable bx plus c divided by the x squared plus bx plus c, because always remember the numerator must always should be a lesser degree than denominator. This means that the top part must actually be lesser degree than the bottom part. That is what we all agreed on when we want to do integration by partial fraction. But once we split it into a partial fraction, unknown variable must be 1 degree lesser than the denominator, of course. So therefore, we actually get the bx plus c because our bottom denominator is an x squared plus bx plus c. And that is how we have to do. Let us move on into solving a sample question and how we can apply this to our questions, right? This rule. First, we have the integral of 1 divided by x squared plus 1 squared. So how do we split into the partial fraction? A divided by x, of course, because we have the first part, the x here, then plus bx plus c, because we have the second part here. Remember, when we have to separate it out, we first take a, x minus a, and take our b as a x minus a squared if it is a square, and c over x minus b if it's nothing. So this is our a, x minus b here. So we a over x, and here bx plus c is for x squared plus 1, plus our dx plus e divided by x squared plus 1 squared. Now expand, remember, always expand, right? Here we get our a. Since a we have x at the bottom, comparing here and here, a is missing the x. A is missing x squared plus 1 squared. So we will use x squared plus 1 squared plus bx plus c. Remember to put the brackets in, multiplied by, since we are missing one x and we are missing another x squared plus 1, we multiply it by that, and we have our dx plus e multiplied by x, since we are missing that. And then continue to expand. Alright, and then separate out the x's. And then you will realize that, okay, if you compare against each other, on the top 1 equal to all this, you will notice that a is equal to 1. Only a is equal to 1. A is equal to 1. And then a plus b equal to 0. C equal to 0. 2a plus b plus d equal to 0. And c plus e equal to 0. Therefore, since a equal to 1, b equal to negative 1. Since negative 1 plus 1 is equal to 0. C is 0. A equal to 1. B equal to negative 1. C equal to 0. Then 2, 1 plus negative 1, which is minus 1, plus d equal to 0. Therefore, d is equal to 1 minus 2 equal to negative 1 as well. And c plus e equal to 0. C plus e equal to 0. This means that 0 plus e equal to 0 and e is equal to 0. So we get integral of a over x. A is 1, 1 over x plus bx plus c. Our b is negative 1. X plus c equal to 0. So we get x squared plus 1. And plus our dx plus e. And our d is negative 1. Our d is negative 1. Our c is 0. b is negative 1. d is negative 1 here. And thus we get negative x plus e. Since our e is 0, then we divided by x squared plus 1 squared dx. And this is our separate fraction. Now let me remove this part for the moment, so we can actually have space to solve our integral. Or maybe I can resize it. Yes, in case you need to refer. Alright, our integral, now let us split it into two parts, right? Integral of 1 dx minus integral of x squared plus 1 dx minus integral of x squared plus 1 squared dx. The integral of 1 over x is equal to ln x, right? And we will add the plus g at the back, don't worry. And for this, let u use in substitution. Let u equal x squared plus 1 and du equal to x dx and half du equal to x dx. So we get the integral of 1 over u half du equal to half of integral of 1 over u du, and once we replace it, we get the integral of ln u du, ln u, which once you replace it, you get ln u ln x squared plus 1, right? And for our integral of x divided by x squared plus 1 squared, we can always use our integration by substitution as well. Let u equal to x squared plus 1, du equal to x dx, and half du equal x dx. And then when we substitute back here, we will get integral of 1 over u square half of du. And this gives us half of integral of 1 over u square du. And once you solve it, you get half over negative 1 over u. An easy way to look about it is half integral of u negative u to du equal to half of u negative 1 over negative 1 equal half of negative 1 over u. Right, so you get negative 1 over u, and once you substitute, you get negative 1 over 2 s squared plus 1. And then once you combine all the terms, these terms, pardon my bad drawing, once you combine all these terms, you will get ultimately final answer you will get is ln x plus half ln x squared plus 1 plus, or you should say minus 1 over 2 x squared plus 1, and always remember the plus c at the back. This is the indefinite integral. Now let us move on. Alright, so we have the integral of 2x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3. Now this looks complicated, but don't worry about it, right? So you will notice that the numerator has a bigger degree than the denominator. What do we do now? Does this mean we can't integrate? No. What this means is we have to use long division to divide terms first. So the numerator becomes a smaller degree than the denominator. And how do we do that? Long division is always not too complicated. Two x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3. Now, what do we need to do to multiply this x squared to get our 2x cubed? Can we multiply 2x? Yes, we can. So we get 2x. And we get 2x cubed minus 4x squared minus 6x. And then you deduct the whole thing, right? So 2x cubed minus 2x cubed equals 0. Negative 4x squared minus negative 4x squared. Since minus negative equals to positive, it becomes negative 4x squared plus 4x squared, and we will get 0. Right? Now negative x minus negative 6x. Negative positive. So negative x plus 6x equals to 5x. And negative 3 minus 0 is just negative 3. And this is the remainder. With the remainder, this means our new integral of 2x plus 5x minus 3 divided by x squared minus 2x minus 3 dx. Now we can see that our numerator has a smaller degree than our denominator, and therefore we can start doing our integration by partial fraction. Let me remove this so we can have more space, or just let me resize it so you can refer it at any time if you need to. To a side. Right. Now we can start forming our partial fraction. Before you start forming your partial fraction, what you can notice is you want to try to make this, use the quadratic formula to split this into two parts, so it's much easier, right, to see it in the form as such, right, in the form as such. So it's easier to know how to make your partial fraction. So you will get integral of 2x plus 5x minus 3 divided by x minus 3 and x plus 1 dx. So what you will get, your partial fraction should be a over x minus 3 plus b over x minus 1, x plus 1. Alright. So always expand, since a has x minus 3 and we want to compare with multiply x plus 1 plus b x minus 3 equals to our 5x minus 3 here, right? Ax expand plus 1, ax plus a plus bx minus 3b equal to 5x minus 3. And separate out the x, a plus b plus a minus 3b equals 5x minus 3. And therefore, what you'll notice is a plus b equal to 5, and then a negative 3b equal to negative 3. And as always, use simultaneous equation to solve it, and you will get your answer, right, for A and B. So we don't even need to substitute. We can just minus A minus 3B equal to negative 3, and then we will get that A minus A equals 0, B minus negative 3B is 4B, 5 minus negative 3 is 8, equal to 8. Therefore, B equal to 8 over 4, which is equal to 2. And therefore, A equal to 5 minus 2 equal to 3. And therefore, our new integral, our new partial fraction integral is 2x plus A over A divided by x minus 3, which is A is 3, 3 divided by x minus 3, and plus B is our 2 divided by x plus 1 dx. Now you can solve it quite easily. We can start to solve our integral. Now let me make this smaller again. Let's separate it first. Integral of 2x dx plus integral of 3x minus 3 dx plus integral of 2x plus 1 dx. Alright, and then this is pretty similar to x squared over 2. Plus integral of, we can separate out the 3, it's a multiplier, x minus 3 dx plus separate out the 2, 1 over x plus 1 dx, and since we'll get x squared plus 3 natural log of x minus 3 plus 2 natural log of x plus 1 plus c, and that will be your final answer.